Welcome back to Intellify. I'm Rasika Ramakrishna and let's continue with the chapter on polynomials. Exercise 2.4, question number 1. Verify that the numbers given alongside the cubic polynomials below are their zeros. Also, verify the relationship between the zeros and the coefficients in each case. Alright, so verifying that particular numbers are the zeros of polynomials is pretty easy. But the important part here is what is the relationship between the coefficients and the zeros of a cubic polynomial. Alright, so let's try and understand the relationship between the zeros and coefficients of a polynomial. So let us suppose that alpha, beta and gamma are the zeros of polynomial p of x. So what does this imply? By definition, you have p of alpha equal to 0, p of beta equal to 0 and p of gamma equal to 0. Alright, so now the major question is, if we are given the zeros of the polynomial, can we construct the polynomial as such from this? Well, the answer to this is pretty simple. So if you're given that alpha, beta and gamma are the zeros of the polynomial, you can say that p of x, the polynomial, can be written as x minus alpha times x minus beta times x minus gamma. So why will this particular expression hold? This is because you'll have p of alpha equal to 0, p of beta equal to 0 and p of gamma equal to 0, and this is obviously a polynomial, right? Okay, so once you expand this, you can write this as x cubed minus alpha plus beta plus gamma times x squared plus alpha beta plus beta gamma plus gamma alpha times x minus alpha beta gamma. Alright, so here the coefficient of x square is the negative sum of the roots. The coefficient of x is the sum of two product of roots. So what do I mean by two product? It is nothing but taking the product of two roots at a time, right? So this is the sum of two products. So that's the coefficient of x, and the constant term is nothing but the negative product of the roots. So any cubic polynomial p of x with roots alpha, beta and gamma can be written as p of x equal to x cubed minus the sum of the roots times x squared plus sum of two product of roots times x minus the product of the roots. Alright, so we seem to have obtained some relationship between the polynomial and its roots. Right, so recall that p of x is given by x cubed minus sum of the roots times x squared plus sum of two product of roots times x minus product of the roots. So in that particular expression of a cubic polynomial in terms of its roots, we have the coefficient of the x cubed term to be 1. But this might not be the case all the time. So your general cubic polynomial can have any coefficient for the x cubed term. Any general cubic polynomial looks like ax cubed plus bx squared plus cx plus d. So how do we understand the relationship between the coefficients of this general cubic polynomial and its roots? So this ax cubed plus bx squared plus cx plus d can be written as x cubed plus b by a times x squared plus c by a times x plus d by a. I have done nothing but just divide this whole thing by a. So assume that alpha, beta and gamma are the roots of this general cubic polynomial ax cubed plus bx squared plus cx plus d. Then by the previous slide, we can write this same polynomial as x cubed minus of alpha plus beta plus gamma times x squared plus alpha beta plus beta gamma plus gamma alpha times x minus alpha beta gamma. So note that these both are different expressions for the same polynomial. So when you are talking about the same polynomial, you can obviously compare the coefficients, right? Because they both have got to be equal. So when you compare the coefficients, you compare the coefficients of x squared and you obtain alpha plus beta plus gamma to be minus b by a. And you compare the coefficients of x to obtain alpha beta plus beta gamma plus gamma alpha to be c by a. And you compare the constant terms to say that alpha beta gamma is equal to minus d by a. So now that we have explicit formulae for everything, we can go ahead and look at our question. So subdivision 1 has 2x cubed plus x squared minus 5x plus 2 and minus 1 by 2, 1 and minus 2. So you just have to substitute each of these guys and see if the p of minus 1 by 2, p of 1 and p of minus 2 are 0. So that I leave it to you. So you can see that p of 1 by 2 is going to be 0, p of 1 is 0 and p of minus 2 is 0 as well. So alright, so verification of the relationship between zeros and coefficients. So this is the important part. So we just discussed that alpha plus beta plus gamma is going to be minus b by a, alpha beta plus beta gamma plus gamma alpha is going to be c by a, and alpha beta gamma is going to be minus d by a. So these are just formulae, but you've got to identify alpha, beta, gamma, a, b, c and d in each case. So here your a is going to be nothing but the coefficient of x cubed, which is 2. B is going to be the coefficient of x square, which is 1. C is going to be the coefficient of x, which is minus 5. And D is going to be the constant term, which is 2. So your alpha is going to be 1 by 2, beta is going to be 1, and gamma is going to be minus 2. Alright, so you know that alpha plus beta plus gamma has to be minus b by a. So add up these roots. So what do you have? 1 by 2 plus 1 minus 2, which is nothing but minus 1 by 2. So check what minus b by a is. Minus b is going to be minus 1 and a is 2. So you have it to be minus 1 by 2. So alpha beta plus beta gamma plus gamma alpha is going to be minus 5 by 2. What is your c by a? Minus 5 by 2. So that checks as well. Alpha beta gamma is going to be minus 2 by 2, which is nothing but minus 1. What is your minus d by a? That is minus 2 by 2, which is nothing but minus 1. So we have verified. Alright, so let's move on to the second subdivision. So we have x cubed minus 4x squared plus 5x minus 2 to be the polynomial, and the roots are 2, 1, 1. So verification of zeros is pretty simple. You just have to check if p of 2 and p of 1 are 0. That is simple calculation and you can do it yourself. So now we have to verify the relationship between the zeros and the coefficients. So you know that the sum of the roots is given by minus b by a, sum of two products is given by c by a, and product of the roots is given by minus d by a, where ax cubed plus bx squared plus cx plus d is your cubic polynomial. So like I said before, the key thing here is to identify a, b, c, d, alpha, beta and gamma. So a is going to be the coefficient of x cubed, which is 1. B is going to be the coefficient of x squared, which is minus 4. C is going to be the coefficient of x, which is 5. And D is going to be the constant term, which is minus 2. And alpha, beta and gamma are the roots. So alpha is 2, beta is 1, gamma is 1. This can be done in no particular order. Alright, so alpha plus beta plus gamma is going to be the sum of the roots, which is going to be 4, which is nothing but minus b by a. Alpha beta plus beta gamma plus gamma alpha is going to be 5, which is nothing but c by a. Alpha beta gamma is going to be 2, which is nothing but minus d by a.